Hello my friends, welcome to my channel. I'm here to talk about this dimmer. I don't know where it come from, but it have two cables here. I have to open it. It says that is some kind of light. It's a dimmer for light. The model is TR767C. 1.6 ampere hour. 1.6 ampere hour. I think this hour is strange here. It works in from 200 volts to 100 volts. 300 watts. 6 and 50 hertz. Yeah. Vilsheng Corporation. Yeah, I never saw it. I'll have to open it and show with you what is inside. Sorry for my English. I'm trying to make videos to the world. Let me see what's inside. It's a little heavy, not so. Oh, it have a inductor for filter, a capacitor, another capacitor, a neon sign, new bulb, resistors, potentiometer, and a triac. The name of the triac is 3410600T. I think that's. Let me open it. I have a lot of screws here. Someone cut the cables. Didn't open it. It's easier to open it and unscrew it or to cut it. I don't know. I found it on a junkyard. I think is it. The place where you can discard old things. Electronic and mechanical to recycle. Okay, very big inductor. What is this? A PTC? This white thing is a PTC. Positive temperature coefficient. I never saw it on an inductor. It's here. I'll try to reverse engineer it. It says 1.6 ampere hour. 250 volts. 1.6 ampere hour. It means that 1.6 ampere can pass through here, and after 1 hour it burns. I never saw it on a fuse. On a fuse. Let me see what is right. Oh, what is wrote on the fuse. 1.6 amps. Okay. Let's try to turn on it. I think that when you push it, when you slice it, the potentiometer, the neon became shine. when you put it up, the new turns off and the whole thing turns off. I think is it. I don't know. I never saw one of these. Big dissipator, aluminum dissipator, single board, single side board. I will put some wire here. If you have something to improve, you can tell me some question or something. I'm trying to improve my channel, but I don't have a lot of money. Like Big Clive and the other bigger channels. Electro Boom. I'm just a frustrated engineer. I put in a bulb series here to see if there are short circuit or something. It doesn't blow up. It's not working. I think it's not working. Okay, the new not shine up. Let me see the fuse. Okay, the fuse is working. The inductor, the PTC, kind of working too. And the thyristor triac. Not shortcut it. The diac. Not shortcutted. Why it not shine? Here it says that the bulb have to be in this connector and the line have to be here. Neutral line. Phase. Line slash phase. Okay. Let me see the new. The new is through a resistor here. And the output. Okay. Maybe it have to have a load here to work. Don't know, the resistor is fine. The resistor is fine. I'll put some load here to see what can happen. So I had to improvise a socket here. I have to solder directly to the bulb, the wires, and let's see if my theory is right. Oh, now the neon's on. You can see the neon shine here. So they throw away to the trash. I think that is working. Let me see. Oh, the maximum right, and the neon stops to shine. Nice. The neon indicates that the dimmer is working. Here, if the full bright, the dimmer kind of stops working and let the electricity and the power pass directly through the bulb. Let me see. It's not so. It's a 40 watts bulb, and it not works through range. It kind of worked in the half of the potentiometer. Okay, it's working, kind of working. Don't know if it's the normal uh, configuration of the gene. I don't know, it's 1.6. Maybe it's not working properly. Let me see. It don't go through all the range. I think the bulb is too weak. Yeah, 230 volts to 100 volts. 300 watts. I don't have a 200 watt bulb, but it seems to work. Nice. I can see the waveforms. Okay, let me see the waveforms. I'm afraid to get electric shock here. It isn't like isolated from the mains. It's only a series 3 in series with the mains. Let me see something here. Where can I put it? Let me see. On the jack. Let's see what is the common. The common is this wire. Because here have a phase or neutral that is straight going to the bulb. I'll take it as a reference. Let me see. How can I look at it? Yeah. Oh, sorry. Yeah. Let's try. You see, 10 times point, 10 times on this oscilloscope. Okay. Oh, typical waveform. Now I will alternate the potentiometer. It stops and didn't pass any voltage. And you will be higher voltage when the sine wave is becoming more and more It's not 100% sinusoidal signal. It kind of distorted here, so it don't pass straight the line to the bulb. It's some kind of regulation here, the action of the track. You control the phase of the track and let pass less of the sinusoid. You can control the passage of the power, passage of the voltage, the sign here. You can control half and almost all the sine wave to pass. A kind of 10%. You can see the voltage here. RMS voltage, a kind of half of the voltage, the mains voltage, is passing here. It cut off the sine wave on the positive and the negative sides of the wave. It's how it works. You're kind of cutting the sinusoid. It's getting higher, and the voltage passing higher, until very close the mains voltage. Here the main voltage, nominal voltage, is 127 volts. So it's not passing all the voltage here. Okay. But the excursion of the potentiometer is not full. I think it's related with the power of the load. It's designed for 300 volts, 300 watts, and I think it's the difference on the excursion of the potentiometer. 33 volts, 34. Okay. Very nice to see it. This diag is letting pass a voltage to trigger the triac. It's kind of a Zener diode bidirectional one. This device here, the blue one, that's the oscilloscope is hooked up. Let's see on the load directly, it's the same. The waveform is the same, like here. Oh, sorry, the series bulb here was taking some voltage drop, because this switch put the bulb on series with the load, in case this case is this plug here, or it passes directly the main to this plug, putting this bulb in shortcut. The current is passing through the shortest way when I press the switch, and then when I press, the bulb became on the way of the current of the main. Because of it, it make it the bulb shine less than the normal, and the voltage here it's a little different. 108 volt, 124 volt. See? Okay, I'll take the schematic of it and share with you. Thanks for the view, sorry for the English, and I'm trying to improve it. See you on the next video. So here is the schematic of the dimmer. The neutral comes and go straight to the output. Then there is a neon with a resistor before the fuse of 1.6 amps. There is a potentiometer with 500 kilo ohms, and in series with it a PTC that seems to be a fusistor, a temperature fuse, not fusistor, because it measures 0 ohms like a shortcut, and the potentiometer is connected with diodes that switch on with a minimum voltage of 28 volts and a maximum 36 volts, and it controls the current that goes to it, and it controls the angle of phase that will be cut to control the power of the output. This resistor here with a capacitor is kind of a filter, and the A1 pin of the triac that is a 4 amps 600 volts. The output of it is A1, the pin in A1 that goes through a inductor to filter the spikes formed through the commutation of the triac, formed with the commutation of the triac to filter it to don't go to the line. It's a ferrite core one, toroidal ferrite core. This capacitor of 0.1 microfarads is to filter the line too, in working together, the inductor and the capacitor. The pin A2 is connected straight to the line through via a fusible by fuse, and the gauge of the triac is receiving the pulses of the dioc. And that's it. That is the simple schematic of today. Thanks, give me likes, and please share it and subscribe my channel. Thank you a lot.